Engineer Man here. Time to learn about memory management in C. No time to waste. Let's do this. The video level today is intermediate. The assumptions I'm making are that you have some C knowledge. Not a lot, just a little bit. First, what is dynamic memory allocation? Dynamic memory allocation is an operation you're going to perform at runtime to allocate an arbitrary amount of memory at arbitrary points in your program. Dynamically allocated memory is stored on the heap, and the actual operation of allocating that memory is handled by the operating system, which your program is running on. There's four functions that generally deal with memory allocation and deallocation. malloc is the simplest of them. It takes one argument, specifying the number of bytes to allocate. It returns a pointer to the beginning of the allocated memory. malloc memory is uninitialized, meaning it could contain anything or nothing at all. calloc is almost identical to malloc, except the allocated memory is zero initialized, and the arguments are slightly different, which we'll see in a second. calloc incurs a slight overhead due to the zero initialization process. calloc is particularly useful if you're dealing with APIs that expect dynamic memory to already be zero initialized. realloc is used to reallocate an existing memory allocation. It expects argument 1 to be the pointer to memory previously allocated with malloc or calloc, and argument 2, which is the size to reallocate to in bytes. If a null pointer is passed to realloc, it will function exactly like malloc. Free is used to deallocate memory and return it back to the operating system for use elsewhere. So let's look at some examples. I wrote this program real quick, and I know I bunched everything together, but I wanted everything to be on the same screen, but just know that this isn't ordinarily how I would write my code. So I've included standard lib.h, which gives me access to the malloc, calloc, realloc, and free functions. I wrote this fail function, which we're going to use later. All it really does is it prints out a message that says memory could not be allocated, and then it exits with a failure code, and we'll be using this later. So the first example to malloc, I have a variable called name, which is a pointer to character. I'm calling malloc, and I'm passing it the first argument, which is the size in bytes. So to get the bytes, what I do is I take how many elements I need, which is 13, 12 for engineer man, then 1 for the null terminator, and then I'm multiplying it by the size of character. Since character is 1 byte, the result is going to be 13 bytes. I could have just put 13 here, but it's a good practice to multiply by the size of a particular data type. On 10, I then check to see if the pointer is null. If it is null, it means the memory allocation has failed. This could happen if the operating system was unable to give your program memory, either because of an error or it just was out of memory. And then finally, I use the string copy function, which is not in the scope of the program. There'll be another video on this, which I'm using to copy the words engineer man into this character array. Second example is with calloc. I have a numbers variable, which is a pointer to an integer. I'm using calloc here. Notice the signature is a little different. Instead of providing the bytes, what you provide is you provide the number of elements as argument 1, and then you provide the size of the data type as argument 2. So in this case, I'm allocating either 4 or 8 bytes on the heap to hold 2 integers. Now whether it be 4 or 8 bytes is based on your computer. And calloc, remember, is zero initialized, so the numbers will automatically be 0. Just like line 10, checking if that pointer is null, and if it is, I'm exiting. And then finally, 16 and 17, I'm assigning index 0 of numbers to the number 1 and index 1 to the number 2. I could put anything in there, any valid integer. Finally, the last example is reallocate. What I'm doing is I'm taking name, previously allocated by malloc, and I'm passing it into realloc. And then what I'm doing is I'm saying 25 times the size of character, because now I need 25 characters. I need 12 for engineer man, and then I need 12 more for space is the best. And then finally I need 1 for that null terminator, equaling 25. I then concatenate this space is the best onto name, and now it says engineer man is the best. Now notice I did name equals realloc name. You have to do that because realloc will return the pointer to the new memory location. Sometimes the location is the same, but sometimes it's not. It's all up to the operating system. And then finally, I free my 2 variables. By calling free name, that releases name back to the operating system, and then free numbers releases numbers back to the operating system. And that's it. Hopefully everyone is smarter having watched this video. If I forgot to cover something or you'd like to request a video, post a comment below. And if you enjoyed this video, smash that like button. And don't forget to subscribe so you don't miss new videos. See you next time.